A container in the shape of a right circular cone of height 20 centimeters and radius 5 centimeters is held vertex downwards and filled with water, which then drips out from the vertex at the rate of 5 centimeters cubed per second. Find the rate of change of the height of water in the cone when it is half empty, measured by volume. So I think a diagram might help here. So we've got this cone, which looks something like that. And we know that the height of the cone is 20 centimeters. And we know that the radius of the cone here is 5 centimeters. So that gives us the volume of the cone, because we know that volume for a cone is going to be 1/3 pi r squared h. So that's 1/3 times pi times 5 squared times h, which is 20. So 25 times 20 is 500. So it's 500 pi by 3. So that's the whole cone. Now note that as the water goes down in the cone, that the shape here is going to be similar to the original cone. And we know that water is coming out here, so that's going to be dv dt at 5 centimeters cubed per second. So if we think about it as the volume in here, that's going to be -5 because we're losing volume inside. Now let's think about what we're required to find. It's always good to get this really clear in our minds. We want to find the rate of change of height, so we want dh dt when it's half empty by volume. So we want dh dt when V is going to be half of the actual capacity, so that's going to be 250 pi by 3. So let's think about the volume of water in general. Now, if we say that the height of the water here is h, the radius is r, and the volume would then be 1/3 pi r squared h. But look at the proportions. R is 1/4 of the height. So this r here, we could say that's h over 4, because these proportions will stay the same all the way down. As I mentioned before, these are all going to be similar, these shapes. So that's going to be 1/3 pi h over 4 squared h. 4 squared is 16, times 3 is 48. So that's going to be pi h cubed over 48. So dv dh, we can now find, is going to be 3 pi h squared over 48, which is pi h squared over 16. Now we want dh dt, so we just form a chain. We can say that's dh dv multiplied by dv dt. Just think, if we cancel the dv's here, we get dh dt. So this is dv dh. dh dv is just going to be the other way up. and then we multiply by dv dt, which is -5. So that's going to be -80 over pi h squared. Now we need the value of h at this point here. So volume of water is this. So we have pi h cubed over 48 is equal to 250 pi over 3. So pi's will cancel here, and 48 cancels with the 3 to give us 16 over here. So h cubed over 16 is equal to 250. So h cubed is going to be 250 times 16 is 4,000. So h is going to be the cube root of 4,000. Substitute that into here. So dh dt is going to be -80 over pi times the cube root of 4,000 squared. We just need to calculate that. So 80 over pi multiplied by the cube root of 4,000. We just need to put a bracket around that, and then we can square it. So that gives us -0.101, and that will be in centimeters per second, correct to 3 decimal places.